In this work, we present UV volumes. It's a new approach that can render an editable freeview video of a human performer in real time. Given multi-view videos of a moving human, we perform high-fidelity novel view synthesis that supports real-time rendering. The left is multi-view videos of a performer. The right is our generated freeview video. For editability, we can easily edit the shape of the reconstructed human by changing the shape parameters of a human model, while preserving interview consistency. Also, we can edit the pose of the performer by changing the pose parameters of a human model, while keeping the texture untouched. Benefiting from the disentanglement of appearance and geometry, we can edit the texture by drawing patterns on the 2D texture. As shown here, the rich texture patterns are well preserved and transferred to correct semantic areas in different poses, which demonstrates that the texture is not only changed as expected under the edited frame, but also transferred to a novel frame with the model dynamics. Moreover, given any arbitrary artistic style, we can render a 3D dynamic human with the transferred texture. We decompose a dynamic human into 2D neural texture stacks and 3D UV volumes. Specifically, we propose the pose-driven and view-dependent 2D neural texture stacks, which encodes high-frequency human appearance, and we present the 3D UV volumes, that encode smooth and view-independent densities and texture coordinates. This allows us to use much smaller and shallower neural networks, to model only low-frequency signals in 3D. Note that the disentanglement of appearance and geometry enables us to achieve high fidelity and real-time novel view synthesis, which is guided by 3D UV volumes. What's more, our generated 3D human performance exhibits high interview and inter-frame consistency. We also implement on the most challenging human 3.6M dataset, with only 4 views available for training. As shown here, our method generates high-quality appearance results in real time, even with rich textures and challenging motions. We compare UV volumes against SOTA Freeview video synthesis methods on multi-view videos. DyNerf takes time-varying latent codes as the conditions for dynamic scenes. Neural Body takes the posed human model with structured time invariant latent codes as input, and generates a pose-conditioned neural radiance field. Animatable Nerf uses neural blend weight fields to generate correspondences between observation and canonical space. Benefiting from spatially aligning the appearance across different poses in a 2D texture, our method produces high-fidelity novel view synthesis, while other methods suffer from blurs, especially letters and wrinkles. For novel human poses, Neural Body gives blurry and distorted rendering results, while Animatable Nerf even produces split humans, due to a highly underconstrained backward warp field, from observation to canonical space. In contrast, our method exhibits better visual quality with reasonable high-definition dynamic textures. Here, the results indicate that, using smooth UV volumes in 3D and encoding texture in 2D, has better controllability on the novel pose generalization, than directly modeling a pose-conditioned neural radiance field. By changing the shape parameters of the simple model, we can conveniently make the human performer smaller, stronger, fatter, or slimmer. As shown here, our model preserves sharp details and consistency in varying shapes. With the learned dense correspondence of UV volumes and neural texture, we can edit the 3D cloth with a user-provided 2D texture, while keeping interview consistency. Furthermore, our model supports changing texture, style, and appearance. Given any artistic style, we can perform arbitrary artistic stylizations on 3D human performance. Given any fabric texture, we can even dress the performer in various appearances, which enables 3D virtual try-on in real time.